Welcome back. We're moving on from the study of number systems and algebra to geometry now in chapter 12. So in chapter 12 here, we're going to be talking about geometric shapes. And this first section, 12.1, and actually 12.2, are focused on steps of the Van Hiele theory of development of geometric learning in children, and actually up through adulthood. So the Van Hiles are a married couple in the Netherlands, and they both teach math. And they developed this theory for how children learn geometry. And so they break things down into different levels. They're kind of thought of as like stages of in the process of learning and understanding geometry. And so the very first level is actually level 0. And I think with the idea that level 0 doesn't really need to, is kind of like where everyone starts, the starting off point. And level 0 is referred to as recognition. At this lowest level, reasoning is visual or holistic, with no particular significance attached to attributes of shapes, except for in gross terms. So a square is a square at level 0 because of its general shape and resemblance to other objects that might be called squares. But maybe things but maybe not any particular properties that are pointed out explicitly with regards to squares. Good. So a child recognizes the certain shapes holistically without paying attention to component parts. So for example, things that may be considered triangles at this stage are, a nice isosceles looking triangle, and maybe even something that's not equilateral, but something like this. But other things that could be considered triangles might be something that doesn't necessarily have straight sides. So might have these weird convex or concave sides on my triangle. So something like this. It has 3 sides, but they're not necessarily straight. So these all might be things that a child at this level would consider triangles, but aren't actually triangles. But these last two aren't actually triangles. But at this level, there are some things that a child may not consider triangles that actually are triangles. So for instance, right triangle may not count for many children, or if I turn any of the above triangles upside down, they may not be able to recognize it as a triangle. Something, like this may not be recognizable. Oops, that's definitely not a triangle, that's why. But something like, let's see, again, I didn't do it. Whoops. Takes a couple tries on the iPad sometimes to draw things that you want to draw. Okay, more than a couple. It's going to be rough. There we go. Okay. There we go. Something like this may not be a triangle, even though it is, or, like the longer, skinnier ones, they may not be able to recognize holistically as triangles, even if the shape is in fact a triangle. Okay, so then moving on to level 1, there's a little bit of this is called the analysis phase, or the analysis level, and an analysis of shapes occurs at this level. This is a refinement of the holistic thinking of level 0, in that it attributes shapes, the attributes of shapes, become explicitly important. A level 1 student who is thinking analytically about a shape can list many of its relevant properties and compare them with those of another shape. Sorting and drawing activities and the use of manipulatives, such as geoboards, which we'll talk about later, are useful at this level. So here the child is focusing analytically on the parts of the figure, not just holistically. So that's the difference between level 0 and level 1. So at this stage, a child might be able to recognize some like these two things as square. So whereas maybe this square that was turned, the student may not have been able to recognize as a square at level 0, even though it in fact is a square. But now, once they're at level 1, they're able to recognize, oh, yep, this thing has 4 sides and they're of equal length. And of course, the following, these 2 drawings may not be a square for someone at level 1, and they're correctly not a square because they don't have sides of equal length. So they're able to now more accurately kind of suss out some of the details based on properties. At level 2, here is where abstraction and relationships are introduced. So abstraction and ordering properties occur at this level. That is, properties and relationships become the objects of study. So environments such as dot arrays and grids are helpful for students who are making the transition from level 1 to level 2. So here, a child is going to be able to kind of understand relationships between figures. So, for instance, they might understand the relationship between, well, rectangles and squares all have, rectangles, squares, and rhombi all have 4 sides. They're all 4-sided parallelograms, right? They have 1, 2, 3, 4 sides, and each of the opposite sides are parallel. But squares and rectangles have right angles, meet perpendicularly, but rhombi do not, right? So they might be able to kind of identify some of the properties that that each of these things have in common. So for instance, squares are a type of rectangle, but rectangle also includes some things that are not necessarily squares, like these 2 yellow shapes, right? And same thing with squares are a type of rhombus, but a rhombus also includes things with not necessarily right angles here, but does have all equal sides. So they're getting these observations that allow them to distinguish between different types of shapes and make more subtle distinctions. And now they can use low-level deduction to justify their observations that they made at level 1. So they may not maybe make very different distinctions between level 1 and level 2, but they can use deduction to justify it, as opposed to just kind of single instance looking at different properties. Okay, at level 3, here is where a more formal mathematical deduction is used to establish an orderly mathematical system of geometric results. So a child might understand some mathematical postulates and theorems and write formal proofs of theorems. So here is something that lower level elementary students wouldn't maybe get to this level, but maybe junior high or high school is something where level 3 might occur. And finally, level 4 is categorized by axiomatics. So at this last level, the difference between level 3 and level 4 is that level 4 doesn't necessarily involve any concrete or pictorial models. So here, the postulates or axioms themselves become the objects that are studied, as opposed to the figures that are understood through axioms or theorems. So here it's just a higher level of abstraction to level 4. This is something that would occur more likely at the college level. Maybe a college level geometry class. Okay, so in the rest of this section, we're going to look through understanding level 0.